Good morning. I'm Jeff Hammond with IGSHPA. Thank you very much for joining our July Town Hall. We'll get started with a few slides for updates to members, and then I'll introduce our speaker today. We have an exciting presentation, and feel free to ask questions at the end. So let me go ahead and get started. We have some news and updates. First off, if you are looking at town halls and dig deeper webinars, just go to the events menu at IGSHPA.org and you'll find a listing of those webinars as well as a form to fill out if you're interested in presenting at one of the town hall or dig deeper sessions. A couple of new items here. We have a business directory. I've mentioned that in the last couple of town halls, so I guess it's not quite as new, but it is relatively new, and it's a benefit for business members. So make sure you check that out. The member portal is very new. It's only been up for about a month. It's continuing to add content. In fact, we have a member only section, and that has a lot of new content just this week. We also have an upgrade option now from individual memberships to a business membership. So we're trying to provide more and more benefits to our members. And don't forget our job boards listing. That's for members, corporate and business, to be able to post jobs. It's always difficult to find people right now. One new bit of information. This is very, very recent. There was a new $13 million FOA announced from Department of Energy yesterday, and they are looking for some of our members to help out. So DOE asked me to announce this. The Office of the Geothermal Technology Office is looking for some experts to review projects that are coming up. Design professionals, developers, community voice to get the word out, and workforce and labor development individuals. So if you're interested, just send an email to our info account, info@igshpa.org, and we'll connect you with the appropriate people at DOE. This is part of the FOA that was announced yesterday on community geothermal systems. So very exciting stuff. Don't forget about our annual conference in December. It's in Las Vegas this year. We're again partnering with NGWA, so we're excited to work with them again. It looks like it's going to be a great conference. We already have some sponsors on the platinum, gold, silver, and bronze level. We still have quite a few available sponsorships, so check that out on the website. If you go to igshpa.org and click on conference, you'll see the conference sponsorship opportunities as well as advertising opportunities in the program guide. We have closed our conference speakers submissions. We received 49. Thank you very much. That's really a great turnout. And we'll be reviewing those speakers in the next couple of weeks and letting everyone know which presentations are selected. Once we have those selected, we'll be able to publish the conference agenda. So shortly, you'll see all of the subjects that are going to be addressed at the annual conference in December. There's still exhibit hall space available, but you can see it's filling up rapidly. So make sure you check this out if you want to exhibit at the conference. We have a great location just right at the front entrance. The entrance is actually right here. So we are in an excellent location this year. CEUs and renewals, make sure you send a chat message to the IGSHPA address if you're looking for CEUs, and we'll record those. Sally will send out a notification of those CEUs once you've accumulated 5 points. It's a half a CEU. Just some housekeeping. If you have questions, please enter those into the chat session, and then I will be reading those at the end of the presentation. And if we don't get to your message, we'll do our best to respond to you with a follow-up email. Please mute your microphone unless you're speaking. That just makes it better for everyone. And we will be recording this session so that you can view it later on, or your colleagues can attend this session if they weren't able to make it this time. I do have just a quick note here on conflict of interest. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and dig deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It's the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of this webinar. So without further ado, let me introduce Roshan Revankar. We're thrilled to have him today. Roshan is a professional engineer based out of California with a mission to make ground source energy affordable. He has expertise in geothermal design and modeling and is also involved in writing standards and codes for various organizations. Currently, Roshan is leading a DOE-funded research project at Melink Zero to develop ambient temperature thermal energy storage solutions to reduce the cost of GSHPs. Roshan has previously served as the executive director at IGSHPA, where he developed training and membership programs and also established the organization internationally. Roshan holds a master's degree in mechanical engineering from Oklahoma State University and is a CGD, CGI, and BESA. He serves on IAPMO USEHC Code Technical Committee and is an IGSHPA, ASHRAE, and AEE member. So we're thrilled to welcome Roshan. I'll stop sharing my screen and we'll look forward to this exciting presentation. Thank you so much, Roshan.
Thank you, Jeff. And let me share my screen here. Jeff, if you can just give me a heads up that my screen share is working just fine.
Looks great, Roshan. Thank you.
Perfect. Good morning, everyone. Like Jeff mentioned, I am certainly thrilled to be here and to talk about some of the things that we've been doing at Melink. The topic for today is really geothermal and solar and how they pair well together. And wanted to use this opportunity to talk a little bit about what we've been doing with our DOE grant and how we are pairing geothermal, solar, and some thermal energy storage into all of this mix. So at Melink, I'll talk a little bit about what we do here. One of our goals at Melink is that we know that net zero is possible. And when I say net zero here, really referring to net zero energy. There are a lot of facilities around the country and the world that are doing net zero. And we wanted to make sure that we show that it is possible with geothermal as well. And in fact, that geo is a major part of going net zero. So why buildings? As most of us on this call probably know, buildings consume most of the world's electricity. This was verified by EIA as well, and a lot of the consumption goes into meeting thermal loads. So people always ask, what do we do with the geothermal? And our short answer to that is basically we do thermal load management, right? We want to make sure that we provide thermal loads both as a sink and source, as and when it's needed by the building at the lowest possible cost for drawing that heat. So just wanted to cover a few things in the presentation today. I'll be talking a little bit about Melink and Melink Zero, just a couple of slides there, and why geothermal and solar were all in one team. I'll talk about an example installation that we did at our own headquarters. And how we work through the DOE funding to do that. And I'll talk a little bit about thermal energy storage versus electric storage. How does that fit into net zero and where we stand as a geothermal community in thermal energy storage. And then, of course, we'll take a few questions at the end of the presentation. So at Melink, real quick, what we do is it's a conglomeration of 5 businesses. Melink, based out of Cincinnati, Ohio, started off about 35 years ago as a test and balance company. So all we did was test and balance as an HVAC test and balance contractor with certified professionals and all that. In one of his stints, our founder, Steve Melink, figured out that there was a lot of thermal energy being wasted out of kitchen hoods. And then he went on to develop this smart kitchen hood controls called IntelliHood, which has really become the pioneer of in the digital control, kitchen ventilation industry. Then about 15 years ago, we went on to start the solar division, and about 8 years ago, started the geothermal division. I'll talk a little bit about what we do with the solar group, and then the solar and geo groups were really merged together as Steve Melink saw these as complementary technologies. With our geo team, we are a geothermal developer. We also have our own pre-packaged heat pump system. So this is in working with Armstrong and developing our own controls and pump system that helps pretty much put a mechanical room on a skid. And we also do obviously a lot of ground source heat pump design and commissioning for our customers. What we like to do is we walk the talk as far as what we do. So the picture here shows our first headquarters, and once we started off as a solar company, you can see there's different kinds of solar panels installed there, and with EV chargers and solar car parking and all that. So this was HQ1, is what we like to call it, 35,000 square feet building, which was one of the first green buildings in the state then at its time. There is geothermal, of course, in this building. Then there's natural lighting, building automation, solar for photovoltaic, and solar thermal as well. With the solar division, the states shown in green are where we've got projects pretty much all over the country, spanning from New York to Hawaii. The solar team really works as a solar EPC, in which they design and build solar parking canopies, roof mounts, and ground mount systems. We've got a large group of customers here with the logos shown on the right. A lot of these customers that we reached out to us started with solar and ended up doing the geo system as well, and vice versa. Did the geo first, and then once the building was up and running, installed solar. So it really tends to be complementary for the way our business works, and really helps with a lot of commercial clients. With the solar team and the geo team, the way we like to look at it is we call ourselves EPCs. We will design, just giving a price estimate, then do a complete financial analysis review with our customers, and come back with the final design and cost for the solar side, get all the permitting and installation done. And a large part of our business is focused at customer training and monitoring the system. So we do this both for the solar team, for the solar side of the business, and the geo side of the business as well. So all of us put across geothermal in different ways to our customers. The way we like to put it across is we talk about the value proposition, talk about what happens when you do geo, and just a few points here that some of you can pick up and run with it as well. With geo, we first focus on reducing the kilowatt demand, and of course reducing the energy costs by almost 50% in some cases. We also focus on reducing water usage and cost, and meeting domestic hot water loads. A lot of our clients don't want to pay for increased maintenance costs with conventional systems, so that's our value proposition as well. And of course, much longer lifetime of equipment. Even as per ASHRAE, geo units run much longer than conventional boiler cooling tower systems. Architecturally, we talk about how green and sustainable it is. A lot of our clients want to market this as a business proposition to their customers as well. We help and assist in getting lead points and improving aesthetics. So we focus on designing the ground loop so that it does not impede future landscaping and its expansion as well. Now, how do we pair solar and geo? How do they go hand in hand? When we talk about geo, we talk about HVAC components that don't need to be installed, and the space that is saved by not doing that and instead going geo. Same thing with cooling tower and the maintenance aspect of cooling towers and the water consumption that the customers have to deal with. We pair that with what happens to the rooftop, especially with rooftop units, the traditional rooftops versus solar rooftop versus going solar. We get a lot more space on the roof to install a larger solar system. So that's some of the value proposition that we put across, and how that helps our customers and clients understand the benefit of both solar and geo. Why geo? A lot of us already know this. Most of our consumption, energy consumption, at least 40% goes towards HVAC, and 5 to 10% goes towards heating hot water. Now, a lot of this is done with natural gas. So here's an interesting stat by the DOE, which talks about natural gas consumption today versus future electrification. And I thought this was interesting. 58% is currently for HVAC heating needs, and 21% is for just hot water. As we move away from natural gas, how does that impact the electrification? 73% is going to be taken by just HVAC and hot water. What does that mean to the grid? It does mean that we need to try and reduce the demand and the energy consumption by HVAC. How do we do that? Geo is a classic example of how we can heat and cool buildings with a lower demand and lower energy consumption. And we make sure that we put this across to our clients as well. So coming back to what we did at our building, in the next few slides, I'll be talking about net zero and the things that we did to achieve net zero in HQ2. That's the second building, and I'll show you a few pictures of that in just a bit here. Well, it's a new construction. So first of all, we want to make sure it's a high quality construction with a large R value overall. We wanted to use geo as a baseline heat source and sink, but not depend completely on geo for the entire heating and cooling for the building. We used a few thermal energy storage strategies. We wanted to show that solar is complementary in how it can produce energy throughout the year. So the energy is fed to the grid, and then we buy back from the grid, just like most solar systems. But the net production versus building usage had to be zero. We wanted to show our clients that you don't need to use the entire roof space to go solar to meet the building energy demand. So we size the solar as small as possible to go net zero as well. So the idea was to go net zero and make it affordable and not have to pay a high cost premium. In order to do that, we worked, of course, with high quality building construction. We decided to also reduce the peak demand for the building. Different strategies we used to do that. Another interesting strategy we used for this particular building was limiting the demand, limiting the peak demand with controls. And I'll show you as we go through the building on what exactly we mean by limiting the demand with controls and how we did that. Another strategy we wanted to use is to make use of time of use rates for electricity. This building does not use any natural gas. It's all electric. So all of the heating is done by geo and other sources. But in order to benefit from time of use rates, we needed to use some sort of storage. And there was a lot of debate about whether we go with thermal energy storage or electric storage. And that's when we approached the DOE and SBIR funding and wanted to complement geothermal with thermal energy storage. So this building is a classic example of how we pair both these together. and what we do with the thermal energy storage and use it during peak rates and charge it during off-peak rates. So the way we tried to achieve net zero was by doing these four things. Demand reduction, we had more space on the roof, which we later on realized we didn't have to use all of it because we sized our equipment correctly. We used high efficiency system and equipment, which used less energy overall. And having a hydronic system provided an opportunity for thermal energy storage. Having the solar system provided opportunity for electric storage. So this is really how we did it in what we call HQ2. So the building on the top here is an older building, but both these buildings have the same square footage. This is based in Cincinnati, Ohio. 35,000 square feet of pretty much office space, meeting space, a small warehouse in this particular building. Similar footprint and similar usage in this newer building, what we call HQ2. This particular building heated and cooled entirely on geothermal. We used 40 boreholes, 300 feet deep, to heat and cool this entire space. For this particular building, we do it with just 4 boreholes, a little more deeper, 400 footers here, but with just 4 boreholes and other thermal energy storage devices that I'll also share with you. Notice that a lot of this is available roof space, which we did not have to use. We wanted to try and showcase parking lot canopy with solar. These are our bifacial solar panels. They produce on both sides. And this particular parking lot pretty much covers all of the energy consumption for this building. It, of course, serves to also charge EVs. Yes, these are all EV chargers. The entire parking lot is filled with EV chargers, and yeah, a lot of the employees like to drive EVs or have been doing so for the last five years. So this particular building is a classic example of a well-managed thermal energy storage and thermal management system overall. Here is what our mechanical room pretty much looks like. I'll go through these pieces real quick. The green is building return pipes and blue is building supply pipes. Our pumping package that I've briefly talked about, we call it the manifest system. It's got Armstrong pumps, all of it built into a skid with expansion, thermal expansion, and storage and all that, and air separators. The 2 pipes going into the ground go to the bore field, which is connected to 4 boreholes. Again, 4 boreholes for this entire building. And we wanted to try out some new strategies, and all of these are controlled with energy valves. Our CEO wanted to just try out what happens with domestic water and what happens if you just exchange heat with the building loop. So here is domestic water exchanging heat with a plate frame heat exchanger. We use 2 air to water heat pumps with the 2 units sitting outside here. These are run when energy rates are really low. This is used to charge a thermal energy storage system. We wanted to have some sort of an electric water heating backup because we would produce so much excess electricity. It would be cheaper to heat water to use for building to heat up the building in case some of these other strategies did not work out. What you see far down here are 2 tanks. These are thermal energy storage tanks using phase change material. The beauty of this particular system is that they change phase at 70 degrees Fahrenheit. So unlike other thermal energy storage, especially for cooling, where you have to make ice at really lower temperatures, which means you run equipment not so efficiently to do that, we can make ice with PCM really and changing phase at 70 degrees Fahrenheit. This can be done even using the ground loop and just flowing water through heat exchangers inside this phase change material PCM tank. We also have a water to water unit, which is connected to a rainwater cistern. So this is a 18,000 gallon cistern that collects the rainwater from the roof. It's all filtered out and all that, and we use that as a heat source and sink, and as and when it's needed. So the controls are smart enough to choose and pick which of these strategies to use to heat and cool the building. Of course, this is not what everyone would do or anyone would do for their building and have 6 different controls or 6 different sources and sinks. We just wanted to showcase the possibilities of all of these. A typical building would probably use 2 or 3 of, or even just one of these to run the entire building. So this is a lot of this work, especially with the PCM tank, was part of a $2 million grant that we received from the Geothermal Technologies office to try and showcase how we could use phase change materials as a thermal energy storage medium. Now remember, all of these strategies are connected to the control system. The solar is also connected to the control system. And at the beginning of this presentation, I talked about demand limiting. What I mean by that is we limit the total peak consumption for this building to 50 kilowatts. The solar can produce 60 kilowatts, and that's what it does throughout the year and generates all the energy needed. But for this building, we limit the peak demand to 50 kilowatts. How we do that is we've identified items in the building that consume energy that are not needed at certain times of the year. So if we see that in the peak of winter or peak of summer, we are closer to hitting the 50 kilowatt limit, then we start to turn off systems and not use energy consuming devices and go back to using other thermal energy storage that may consume lesser energy at that time. So what the thermal energy storage system lets us do is be able to move and shift the load as and when we want to meet the demand. What this really does is the way Ohio and our area is located, it sets a ratchet and they charge you for kilowatt consumed for the entire year. So we really wanted to make sure that we draw that bar lower than what is actually consumed by this building. Here is just a schematic of what I just showed you. 16 heat pumps throughout the building connected with the pumping station to all of these 6 sinks and sources. The baseline is our bore field, which is 4 boreholes at 380 feet, connecting this all connected in parallel. And then these other sinks and sources that I briefly talked about, including an air-to-water heat pump, a water-to-water heat pump connected to a rainwater cistern. And the focus of thermal management here is really the PCM tanks that change phase at 70 degrees Fahrenheit. So this graph really has a lot of things going on here, but I just wanted to show the times in the day where it really changes phase from liquid to solid. The tanks can provide 35 ton hours for 35 ton hours of capacity when it's charged and discharged. So this is a diurnal thermal energy storage system, which means we can change phase once every day. So at night, if it's summer, we want to make sure that it's solid in the morning and then liquid by 4 p.m. and then go back to solidifying the thermal energy storage at night when the energy rates are lower. We did a little bit of study on whether we should go with thermal energy storage or electric storage, and this is a cost comparison of the latest energy storage or electric energy storage, lithium ion storage that's available in the market and the cost comparison. What we noticed is it was 20 to 30% cheaper to store thermal energy versus electric energy when we could do thermal energy. So for example, you needed to have a hydronic system to be able to do that, which paired really well with Geo and our TES system. So to store, to be able to convert electric and store electric, convert it back to thermal, and every time you convert energy types, you lose efficiency. With thermal, you could store thermal and use thermal. So you're not essentially changing the energy type here. So that really helps us to save and make it more efficient. I do want to point out that when we do thermal energy storage, it not necessarily reduces the energy consumption. It helps a lot to drop the demand, peak demand for the entire system. Because thermal energy storage is essentially you are just storing energy. So you are spending energy to create energy, store it, and then use it back. So essentially you're not saving or you're not reducing the energy consumption overall, but by shifting the peaks, you are able to reduce the peak demand for a particular system and a building. A simple schematic of how this would work is you could pair a thermal energy storage system with either a ground loop or an air-cooled heat recovery chiller. And during downtimes, use these systems to charge the battery, and during the day, just circulate water through it to run your indoor units or rooftop units. This could also be paired with hot water storage. So you could use thermal energy just to transfer heat between these two systems and use the Geo just to sort of top up the battery, so to speak, when the balance isn't there. Like I said, it really makes sense to use thermal energy storage when there is time of use savings. We compared the payback windows, and the payback windows with time of use savings for thermal energy storage was less than 5 years compared to without thermal energy storage. How did that compare to our Geo system? Like I said, our goal was to try and cost reduce Geo. We dropped it from 40 boreholes to 4 boreholes. We were able to do that. If we were to do 100% Geo, it would probably be around $200,000 cost in the Geo side of it. With a smaller thermal energy storage system, we were able to reduce this by almost 25% in cost. This is for an office load building in Ohio. A quick snapshot of our energy bills from Duke Energy. This does vary, but overall in the entire year it is zero. So we end up paying zero energy cost to our utility. Just a couple of more snapshots of a test scale lab that we have for testing different thermal energy storage systems that are paired really well with Geo. And here's some of the stuff that we've been doing with the funding from DOE to be able to try and test different types of heat exchangers for thermal energy storage system. Our partners, we work closely with Oak Ridge National Lab, Dr. Liu, and a couple other professors at Oak Ridge and the University of Dayton who've been helping to come up with a program that helps everybody else design thermal energy storage systems when paired with Geo. So this particular software lets you input the temperature of phase change, temperature of the ground, and then gives you sort of the optimum ground load design for a thermal energy storage system. And sometimes, quite honestly, it may not work in all types of buildings because the building load profile is very, very important. We tried to do thermal energy storage in a residential system, and it did not work because the residential use profile was very different compared to an office load profile. And it really worked really well in office load profiles in the Midwest, say, for example. So we have a software tool, and I can give you guys access if you want the tool to see how this would pair with some of your projects, and try to fit in some sort of thermal energy storage in designing the geo system. Again, just a quick example of what the thermal energy storage device would look like. And then just to summarize what we did here, this is a slide I've used previously. With geo and solar, the way we've paired it together is these are independent sources and sinks. The geo being the heat source and sink, or the thermal source and sink, and paired really well to help reduce the peak demand. It also helped create more space on the roof for solar. With solar and some of the other projects that we've done using both solar and geo, that created more space for solar to produce more energy and go towards net zero. Another building that we did was a small office and a large warehouse. They did a lot of storage. The entire building was able to go net zero because of the space that we created on the roofs for solar. And the solar came in much later, after the building was up and running. So they both don't need to be done at the same time. They could happen at different times during the project, and they both really complement each other really well. The geo being most important to reduce peak demand, and the solar being able to produce all the excess energy needed to run geo, because it does not depend on natural gas anymore. So that's some of the things we've been doing, and happy to answer questions here, Jeff.
Great. Thank you so much, Roshan. That was a fascinating presentation. I do have a question for you. We have some others that are coming in the chat session here. Just curious, what was the tonnage of the water-to-water equipment and the air-to-water equipment for this building?
The air-to-water equipment were 5-tonners, so 2 5-tonners. And the water-to-water was just 1 unit. It was also a 5-ton unit. So just really small units just to charge and discharge the battery. The entire building, and I probably didn't mention this, is about 60 tons of HVAC equipment in the building.
Okay, very interesting. That really helps with demand reduction for sure. All right, let me take a look at the questions we have coming in. The first question from Mehdi is, will the slides be available? And we do have this session recorded, so you will see an email from IGSHPA with a notification that the presentation is available on our YouTube channel. So all of this will be available in the next couple of days. Usually it only takes us a day to turn that around. Next question is from Bill. He asks, is anyone aware of legislation that recognizes geo-exchange loops as thermal energy storage infrastructure? I don't know if you have run across that, Roshan, or if anyone else has.
In our projects, we've not really run across that, Jeff. There is some legislation which recognizes, well, I wouldn't say legislation, but it's more in code. So some of the code work that we're doing with the Uniform Solar Energy and Hydronics Code talks about geo being a thermal energy storage device. Well, not really a device, but just thermal energy storage in the ground, and categorizes it as one. But I'm not aware of any legislation per se that recognizes it as such.
Okay, thank you. Yeah, we'll have to keep looking at that. That's an interesting topic. Joe asked the question, are geo and solar tax credits factored into your financial analysis?
No, we did not, because we wanted to show and prove that this can, and again, I don't want to get into the political side of it, the tax credits are important. We recognize that, but as something that we do on our own, we didn't want to factor it in, and wanted to put it across as this is something just bonus, sort of cherry on top of the cake when it comes to tax credits. It is very important. It is a important decision maker for a lot of our customers. But in our analysis, we did not have to factor that.
Okay, great to see the $0 electric bills too. Dan asks the question, can the thermal storage tanks be made in custom sizes?
So currently, we are in the process of making them in 20-ton-hour capacities. They can they come with 4 pipe systems. So 2 supply return to charge and 2 supply return to discharge, which means that they can be connected as just like you would connect electric batteries, where you can charge them independently and discharge them independently. It's really hard to scale these batteries because the larger you go, the way the PCM works, phase change material works, is you've got to have certain spacing between the heat exchanger and the phase change material. Because phase change material in general are not great at conducting heat, so they have to be tightly spaced. That's something we're still working through details, but they will be available in 20 to 25 ton hour capacity.
Very good, thank you. That's quite fascinating. Mike asks the question, what's the square foot of the solar thermal collectors, and where were they located in the pics that you had?
So I showed solar thermal collectors in the first building. It was located on the south facing wall, not on the roof, it was on a wall. But we have not used solar thermal collectors in the new building, which is what I focus this presentation on. So it was located on, let's see if I can find it here. It's located on this wall right here.
Okay, so not a huge
Not a huge
footage. Okay, very good. Thank you. Steve asks, seems like the showcase mechanical room seems to lack piping insulation. Is there a reason for that?
We debated quite a lot. We designed the system in a way that we may not need insulation, but we kind of learned the hard way, so we had to insulate the rest of the building piping. We did have a few condensation issues because the controls were still being tidied up a little bit. But currently we don't need to insulate the piping because we try to run the whole system in a way that the whole system is really efficient and in that sweet zone where the heat pumps give you great efficiency. So, but yeah, we did have a few condensation issues which we rectified as we learned through the project.
Okay, great information. Mehdi asks, similar to solar, are there calculators for calculating the upfront cost of geo?
Can you repeat that? For our
Yes.
general, I think it's more of a general question. Yeah, there's quite a few tools out there to collect. I mean, you would have to plug in a few inputs because geo costs vary drastically throughout the country. So you do need some inputs, but there's one tool I can think of is the best calculator BEST by IAPMO. A few IGSHPA members also have calculators, and then a lot of the manufacturers have calculators as well that you can plug in costs per foot for geo, and then you can get a comparison, an energy comparison and first cost comparison of geo versus conventional systems. So yes, there are tools that are available. And then of course, if you want to take it a step or notch higher, you can go with purchasing software tools that design geo systems that also do those calculations.
Thank you, Roshan. Greg asked the question, what is the phase change material that has a melt point of 70 degrees? What sorts of PCMs have you evaluated, and which ones pair well with ambient loops?
So one of the things we did with we're trying to get to the 70-degree PCM mark is work with the best minds in the industry. And when I say that, I really mean it. We are working with the top-notch professors at Oak Ridge. There is no PCM in the world that can, there is no cost-effective PCM in the world that can do 70 or 65 to 75 degrees phase change. We initially evaluated organic PCMs just to make sure that it can be done, but those were really, really expensive. We wanted to try and get our costs below $500 a ton hour capacity, first cost. So that was our target. So we started with organic PCMs and then slowly moved towards inorganic PCMs. The disadvantages with inorganic PCMs are basically salt-based PCMs. So the salt tends to settle and separate and settle down. So if you can imagine, if the salt is settled down in a big tank, you're just left with nothing but water on top. So that was the biggest disadvantage, although inorganics can be really, really inexpensive. So we've come to a balance between the two, and they're called really eutectic PCMs. So they've got some sort of material that makes sure that they don't separate the salt from the hydrated part of it, from the water part. So that's kind of the secret sauce per se currently. But our goal is, once we hone in on that particular chemistry, that it will be made available to anyone and everyone, and just make it available for everyone to develop and use. So
okay, I think you may have.
The cost of PCM, because phase change materials in general have been are still very expensive for such large scale deployment, unless you're able to bring down the cost per gallon of PCM.
Okay, thank you very much. I think that may have answered Gino's questions as well about the material in the thermal storage. Okay, those are all the questions I have right now on the chat window, but I do have one other question for you, Roshan. You mentioned 50 kW demand is the limit for this building. What do you think, or did you calculate the actual demand would have been with either a system that was just purely geothermal, or one that might have been conventional equipment like rooftop units?
So the way we came to a conclusion for 50 kilowatts was just based off of just doing a total of all the equipment that was running in the building, if it was running at peak condition, and then coming sort of back calculating what our goal should be for this building. Because we didn't have a direct comparison. Now, of course, HQ1, we knew what its kilowatt consumption was, which was a little bit higher than 50 kilowatts. They did have some other equipment running in there as well. But for our building, we sort of had to back calculate, total up all the heat pumps, total up all the other equipment that's in the building running, and say, you know what, if we have to do this, what are the things we can shed off, and so on. So it was more empirical than anything else. What we did realize is, at times when our controls failed in the first year, from 50, we did go up to like 65 kilowatts. So that set our ratchet to 65 kilowatts for the entire year. And we were like, we really needed to hone it down to 50 kilowatts because that was our goal. So just a comparison for the first building, because it had the similar square footage and 100% geo. So we knew what that consumed, and we had a target for our building that we wanted to hit.
Okay, so significant kW reduction, it sounds like, versus a conventional system.
Oh, conventional system, definitely. I mean, we did some math and some software calculations. We dropped from the 80 plus kilowatts to 50 kilowatts.
Okay, impressive. Great. I don't see any other questions. We do still have some time. We have about 9 minutes. I want to be respectful of everyone's time here. Our goal was to wrap up at 12:30 Eastern, 11:30 Central. So we'll just give everyone just a few minutes if they have any additional questions, if that's okay with you, Roshan.
Sure. I do want to plug in the fact that IGSHPA is doing a great job here, and with these town halls and the Dig Deeper seminars. So congratulations, Jeff, on making this happen. I think it's really informative for our community at large. You guys are doing fantastic.
Well, thank you very much. We certainly couldn't do it without wonderful speakers like yourself. So that definitely helps. And we continue to ask for additional speakers for town halls and Dig Deeper sessions. If you want to go to the IGSHPA.org website, you'll see an events calendar on there, and there is a form to fill out if you're interested in speaking at a town hall or a Dig Deeper. So that's great. All right, with that, I think we'll wrap it up. Thank you again, Roshan. Excellent presentation, very informative, and I look forward to our next presentation. Thanks everyone for joining us. Have a great day, and you'll see an email once the presentation is online. Thanks again.